Hi, good morning. Hi, everyone. Thank you for joining us for the Data Center Power and Cooling Sustainable Design and Innovation Pre-Show. I am Devon. Just one second. I'm Devon, the publisher at W Media, as well as your host for today. I'm really excited to welcome you all to explore the latest sustainable designs and innovative power and cooling solutions to solve the pressing energy supply and environmental concerns brought by data centers. Joining me on the pre-show today, we have Clinton Marshall, the Deputy Director for Solutions and Channel Development from our Platinum sponsors at Legrand Data Center Solutions. We will discuss how power monitoring and measurements can be used to meet rising data center demands while delivering an IT environment that is able to achieve evolving business usage, regulatory, and financial goals. So without further ado, let's jump into our first session for today. Hi, Clinton. Welcome to the show.
Hi, everyone. Thanks for having me.
Legrand has a suite of innovative solutions to meter and monitor a data center's power and cooling efficiency. Tell us more about Legrand's innovation in the white space and how these ultimately benefit your customers.
Thanks, Devon. Yeah, look, our innovations span across different areas in the data center and in the white space. And most of our important innovation we provide is a common platform for metering and monitoring the environment of the data center. Customers with their own private data centers or occupying a shared facility need to understand what their IT equipment is doing in real time and historically be able to predict the power and cooling needs for the future. And this is achieved by using data from sensors that are provided across our platform.
Why is it important to meter and monitor a data center environment? And what can this tell us about the power and cooling requirements of a data center?
Well, I guess, customers who meter and monitor their data center environments do have the ability to report on events that occur or be able to prevent events from occurring in the first place. Some examples of an event that could happen at a data center is identifying a cyber attack. This is front of mind by many customers where the IT equipment is under a denial of service attack, or sometimes it's being able to identify a failing or failed power supply in a piece of IT equipment. Monitoring of the cooling is they need to monitor to make sure that the cooling is sufficient for the IT equipment, because over time, the equipment, the locations, and the power loads change. Therefore, the cooling requirements change as well.
What are some of the challenges that data centers can face if they do not effectively monitor their facility?
Well, it would be like driving a car with your eyes closed. You can't see what's coming. You're not able to react to something or prevent an accident if you've got your eyes closed. So if there was an accident in the data center, you wouldn't know what it is or where the accident happened. If data centers don't effectively monitor their facilities, they have unreliable ways of understanding the situation due to the lack of data. Without data, you cannot understand the situation even before or after it happens. Monitoring the data center will help operators with some flashy terms like operational intelligence, being able to meter and monitor the power and cooling elements, having situational awareness by understanding the situation as it unfolds, by trending historical data, to determine a situation even before it happens in some cases, and to prevent preventative incident management by monitoring the environment and informing other systems or a person of those events for action.
Good. So data center consumes a huge amount of energy and emits tons of greenhouse gas emissions. Legrand has a corporate social responsibility strategy with the aim to reduce energy consumption and a 30% reduction of greenhouse gas emission by 2030. What existing problems prompted Legrand to initiate this, and how do you hope to achieve the strategy?
Well, I think I'm not going to single out one company being who I work for, because I believe that all manufacturing businesses have got a responsibility to reduce their footprint on this earth. The existing problems are industry-wide. It's not just one organization, and those issues still exist today, with some manufacturers supplying products into the data center spaces without publicly committing to a greenhouse gas reduction program. Legrand have got a science-based program led by the World Wide Fund for Nature, United Nations, and the Carbon Disclosure Project, where we have a long-term standing commitment to limit the impact of our activities on the climate. Our responsibility is to limit the carbon footprint of our activities and contribute to reducing that footprint of data centers. And we do that by way of some of our energy efficient data center tools. Our goals for 2021 are applying a circular economy principles across all of our R&D centers, and to recover at least 90% of our waste produced by our global businesses. And looking forward into the not too distant future, we've also publicly committed to a 30% energy reduction by 2030 across all of our global businesses.
Looking ahead to the future, with more advanced technologies like artificial intelligence, machine learning, and cloud computing increasing the need for data center capacity and ample power, what problems for data centers might come about from these new technologies, and how is Legrand preparing metering and monitoring innovations to efficiently meet these growing power consumption needs?
Well, for those of you who know me, I'm kind of a little bit nerdy, and I'm really excited to see what the future holds. And working for Legrand, or for Raritan for 17 odd years, and now under the Legrand banner, I'm seeing a lot of ideas that we've talked about actually being implemented at a very quick pace. And I can't share details, but I can tell you that since Raritan launched a platform over 10 years ago now for the data center white space, it was designed in a way to be flexible and agile for the needs of customers and the evolving industry. This platform started with the Raritan brand, and it was first seen in the industry first programmable network connected rack PDUs, sometimes known as intelligent PDUs. And this platform is now spread across into other products like the Legrand network connected PDUs, and also the Servertech network connected PDUs as well. So this platform is spreading into other areas of the data center, and I think this is a really important proven sort of technology or proven platform that's been around for many years, that is actually already being adopted by different brands, but also different areas of the data center. So we've already started the innovation of that many years back. So I'm really excited to see what the future holds with AI, machine learning, etc. So, yeah.
Thank you so much, Clinton, for joining us today. It's clear that it is not only important to have effective power and cooling solutions for data centers, but also metering and monitoring systems to make sure the solutions are running efficiently. Thank you, Clinton. Now it's showtime, and I'd like to welcome everyone who has just joined us for W.Media's Data Center Power and Cooling, Sustainable Design and Innovation Show. I'm David, your host for today and W.Media's publisher. Don't worry, if you missed our pre-show, we will send you a recorded version, including our excellent interview with Clinton Marshall from our platinum sponsors at Legrand Data Center Solutions. It's great to see so many of you tuning in today. Power and cooling solutions for data centers are critical to keep facilities and business online, especially as the need for data centers and greater data capacities continue to grow. Running data centers are having varying impacts on the environment by consuming approximately 1% to 3% of the world electricity supply and pumping out 2% of global greenhouse gas emissions. So I'm really excited to put the latest power and cooling innovation under the microscope as we strive for an efficient and environmentally friendly data center future. Coming up on our show today, we will welcome back Clinton Marshall for a thought leadership presentation. Clinton will be representing Raritan, a brand of Legrand Data Center Solutions, who are also our platinum sponsors for today. Legrand Data Center's offerings comprise one of the largest team in the industry devoted to both standard products and custom solutions development, resulting in satisfied customers in more than 100,000 data centers globally. Next up, we will kick off the first of two panel sessions focusing on the best practices and strategy for sustainable data centers. We will be joined by Tamas, and the director of H1 Systems, our silver sponsor. Tamas is a data center infrastructure expert and consultant who has worked on several dozens of data center facilities projects from scratch. We will also be joined by Joshua Au, the head for data center and information technology shared services at A-Star. As an expert and active member of the data center industry, Joshua will share how data centers can run as little waste as possible, particularly considering that some facilities currently estimate up to even 90% of the electricity they pull from the grid. In our second panel, we will discover the latest power and cooling innovation keeping data centers alive. We will welcome back Clinton for further explore the future trends in the data center power and cooling market. Joining Clinton will be Kevin Wong, the managing director at DC First. Kevin brings with him over 30 years of executive management and leadership roles in the ICT industry and experience of designing and constructing data centers in Singapore and Indonesia. Both panel sessions will be moderated by James Riggs, the Associate Director of Acadis UK, who is well-versed in running data center projects across the whole data center stack within 14 different countries around the world. We love to hear from you, so please send in your questions or opinions at any time during the event by selecting questions marked icon in the GoToWebinar window. Please include your name, job title, company name, and country in your questions for a shout out. We will be giving away a $50 Amazon gift card to the individuals who ask the best question. So remember to send your question, to send yours in throughout the show. I'd like to give a big thank you to Legrand Data Center Solutions for sponsoring this giveaway. Before we jump into our first panel, I'd like to say a big thank you to our platinum sponsor, Legrand Data Center, our silver sponsor, H1 Systems, and our bronze sponsor, Anium Technology, as well as all our supporting partners for bringing this event to you. You can get more details of any of these great organizations on our website. Now, before I hand it over to Clinton for a fascinating thought leadership presentation, here's a quick video to show you what Raritan is all about. Yeah, sorry.
Are we good to go?
Yes, we're good to go. Thanks. Thank you, Clinton.
Great, no worries. Thanks for that. So thanks for this opportunity to provide this few slides to you. It's quite, as mentioned, I've been around for a long time within Raritan, and I've seen a lot of our solutions be adopted by different customers. And I think one thing that I always see and hear is how can I manage my infrastructure? What sort of tools do I need? And sometimes customers will say that they don't need it, or they can do without monitoring tools. So this is just a few slides just to get you thinking about how can you actually manage your IT infrastructure without monitoring tools. I think all businesses have experienced some type of system outage or network interruption or some event relating to their IT infrastructure that's impacted on their business. And one of the things that some individuals have realized is that they might be fresh out of university. They may not have had a role as an IT manager, or it's their first time as a facility manager for a data center. And these individuals have not experienced such an event or an outage that they've been responsible for in the past. And that's impacted their business. So there's nothing wrong with these individuals. It's just a matter of time before an individual will experience some sort of outage. Some businesses have limited budgets to operate their IT infrastructure, and they end up spending more money to maintain it, or reacting to events that occur. But if you're not monitoring your IT infrastructure, how can you manage it? And if we look at an example where a lot of us are working from home today, if there is something happening in the data center and that server is maybe heating up, or there's some sort of fire or event, or the hard drive gets full, you need something to monitor it. And we usually use software tools for that. But if you're working remotely from that IT infrastructure, sometimes software tools aren't going to do it. So as mentioned, I'm from Legrand, and today I'm representing the Raritan and Servertech product lines of Legrand. And these are all focused around the rack and the white space. So if we look at an explosion of a rack, most of what you see in this diagram is generally inside the rack. And as you can see, some, if not all, of you here today are being impacted by a server, have been impacted by a server or network outage in our personal or professional lives. I know doing many of these webinars, my Wi-Fi will drop out or the internet will drop out, and we've all been impacted by something. So on the left-hand side, we've got IT managers that are typically involved with servers and network infrastructure. But there's a lot of other infrastructure that helps to manage and maintain and monitor these servers that are providing us with the services like what we're using today. And there's a lot of related tools such as the rack PDUs, networking devices, and IT equipment that all connect to each other, and they are all core to what businesses are using and what we're all been using today. Just to acknowledge, these are screenshots from our DCIM tool. So these business tools and services that we've been using, some of the examples are on the screen, they're all running on IT infrastructure or servers. And all of these servers need monitoring, just like our cars. Most things have been running for years. Servers need maintenance too. So this could be preventative maintenance, or it could be maintenance that's required after an incident. And these could be monitoring for cyber attacks, power supplies, system health, and the environment that the server's running. So one thing that's important is being able to access these IT equipment over the network. Now, there's many different types of networks that can be used to access equipment. whether it's your local network if you're in the office, a wide area network like over the internet, using a VPN to maybe get into your corporate environment, or even the 4G network. And these IT equipment could be a range of lots of different devices. Basically, any device that has some sort of connectivity, network interface, or KVM connection or serial port is something that's typically needs to be maintained and monitored. So if we have a look at a quick example, if you can't access a server and the customer knows what server they can't access and they know where it is, what's the customer going to do? If customers are sitting at home and they can't ping their IP, they can't ping their server, and someone said, oh, something's not working, typically they would go to the server, pull up a crash cart, and have a look and see what's happening with the IT device. This crash cart is commonly found, I should say, in data centers where an operator might need to wheel up a crash cart, plug in a monitor and a keyboard to see what's going on with the server. This could be done, sometimes they need to turn off the IT device and turn the power back on if that wasn't responsive. And this is often the case when you've got that blue screen of death. This could be done with a network-connected rack PDU, which provides outlet switching, the ability to control the power to the IT device's power supplies, and it could be done across multiple outlets across multiple network-connected rack PDUs at the same time. To see what's going on with the server, you could use a KVM switch and connect that to the correct interface type to see the video output, just as if you were there. Add a USB for keyboard and mouse, and when you connect these two devices, hardware devices together, you then have a single remote user interface to see what the server is doing, shut it down, power it on, power it back off again, watch the device boot up, and remotely diagnose the issue. Network connected rack PDUs are part of the story here, and these are providing different types of functions depending on the model. On the right-hand side are 3 different types of network connected rack PDUs, all from Legrand, just different brands of Legrand. So some of them are providing with the power monitoring, power control. They integrate to rack access control systems and a lot. If we look at a typical customer, they have multiple racks across multiple locations, and these locations are definitely remote to where the operator is. They're not driving from suburb to suburb or city to city, or in sometimes country to country. So these have got a typical organization would have 2 data centers or 2 facilities that they host their equipment in, like a co-location or shared facility. They also have remote offices as well. And of course, the work from home that we're all been experiencing now. If we look at a scenario that could play out, here we've got some network monitoring software on the top right-hand corner showing it's monitoring the activities or events that are happening on the network or that are happening on the IT infrastructure. If there was an incident on one of these servers, that software would be monitoring the IT people. The IT people would receive a notification of some sort. They would then know which IT device that related to. They would then come in through a KVM solution, and that KVM solution would be able to show them a list of all of the IT assets of whatever that asset or IT device might be. They would then be able to find that IT device and then access it as if they were locally to the device to remediate that incident. And finally, I think that the whole purpose of this sort of thought leadership type presentation was really to show a benefit to the customer. So when we look at when an incident does occur, what we're trying to do here is shorten the time it takes to respond, because you're monitoring what's happening and you're aware of what's happening. And we're also shortening the time it takes to repair, because we're giving access to the system. We're giving a level of access to a system that software would never be able to provide. And if it was the network that was the issue, then you need to have a tool that can get you out of band access or access via another network method. This is key for customers to try and understand that, yes, you might need to dig out that old KVM switch that you've had in the backyard for a long time. Maybe it just needs a firmware update and you've got modern secure access via your existing investment. With the Raritan stuff, which I've been using for a long time, and supporting and sort of consulting and providing solutions for customers that have got different makes and models of devices, they've invested in virtual infrastructure, those two can be accessed and controlled from a KVM solution, so that the operators don't need to be jumping across different systems to access and control their environments. So the final slide here is really just to highlight that there's a lot of moving pieces. There's a lot of things that vendors and customers and tenders call for. And to summarize all of these different things, whether it's monitoring your power, doing asset management, controlling access to the rack while you're not around, or using a DCIM tool to document and have a nice clean procedure and process to follow. All of this really relates around to one rack, you know, and in some customers, they have hundreds and hundreds of racks. So being able to effectively monitor your environment and then access that environment when something happens, or to do preventative maintenance to make sure that something doesn't happen, then that's I guess what customers need to be aware of, is that there are tools out there that do help customers that have got and run their own data center facilities and IT infrastructure to service those facilities, or they're a customer that's relying on a third-party data center operator to provide that access and control for them. So that concludes my presentation, and I will stop sharing my screen and hand it back, if that's cool.
Sorry. Thank you for the excellent presentation, Clinton. You can find out more about Raritan's leading power management solution and DCIM software for data centers of all sizes by visiting raritan.com, and follow them on social media. You can also get more information about Legrand's complete offering of data, power, and control solutions at datacenter.legrand.com, or by following them on social media. Now, let's hand it over to James to begin the first of two panels. James? James, you're on mute, sorry.
I wonder if that's a little better. I think you're on mute is the new catchphrase for 2020. As I was saying, so good morning, Joanne, Selamat pagi, Vanakkam, to everybody that's on the call today. The slide we have on the screen says, keep the lights on, keep it cold. This is what I was told by data center engineers in a large co-location facility in Europe. This is what they had been instructed to do. Is it correct? Is that exactly what should be happening? When we look at our first question to both Joshua and Tamas pleased to meet again and to share with. I think that data centers really, if we can have the next slide up, thank you, that are pumping out a staggering 300 million metric tons of carbon emissions globally, can waste an incredible amount of electricity, up to 90% of what they pull from the grid. A 10-watt program running on a server in a data center could require over 32 watts of power to support that. But Joshua, you manage A-Star's corporate data centers. How do you make sure those facilities run with as little waste as possible?
Hi, James. I think we've had some conversations prior to this session, but it's good to be. I'm going to be very forthcoming about this. In the end user space, our priorities are a little different because we need to think about reliability, availability, safety, security. So amongst all the priorities, if you talk about sustainability and efficiency, it's always low on the priority list because we follow the priorities of senior management. Now, having said that, if we could make things more efficient, we would want to. So from that perspective, there are some things that could be done, such as shutting down comatose IT, minimizing electrical conversion losses, and eliminating overcooling. Now, these are, shall I say, hygiene issues. Any facility manager worth his weight in gold knows how to do this. But having said so, sometimes there are trade-offs. And these trade-offs, they do necessitate some losses. When I use transformers, when I use UPSs, when I have N+2, 2N, now all of this is to give me a buffer, but this buffer comes at a very high cost. So there are trade-offs, but having said so, I think if we follow common sense, for example, most of us, we adhere to the separation of hot and cold air through hot cold aisles and through blanking panels. All this is hygiene issues which can be done very easily.
That's right. So they are really some basic things, and sometimes it's the basic things that can sometimes be forgotten. It's good to make sure and have that reminder. Thank you. Now, Tamas, when we look at our next question, so we can have our next slide, please. H1 systems implement a unified approach to energy management. So how does that work to help to run a data center without waste?
Okay, thank you. Good morning, everybody. So I completely agree with what the European engineers said to keep lights on and cold, and also I fully understand Joshua's standpoint that reliability comes first and sustainability is sometimes a nice to have. But during this panel, let me address this from a disruptive perspective. So to address this question, we need to see the whole elephant, not only part of it. Cooling, transformers, these are very important parts of it, but the whole emission impact of a data center is coming from the ecosystem, the whole ecosystem. And actually, the biggest waste source, if we go back to the roots, is actually the coders, the application writers. So what they are doing, they are actually not taking consideration energy usage of their applications, of their coding at the very beginning when the code exists. So of course, that's not the topic of discussing data centers. So coming back to our engineering field, the next item we need to touch is the hardware we are using. The hardwares we are using are limited to certain threshold conditions, ambient conditions. But these ambient conditions has to be challenged. So this is what ASHRAE, the Green Grid, is doing for a certain amount of time. And this needs to be stretched further to reach less waste in the data center. But what we've seen to happening, can we go back, please? Yes. What we've seen happening is that the conversion between ICT infrastructure and data center is a good way to reduce emissions. Because in case we are providing, for example, cooling and power supply based on sensors data only, which is very important, then we are making a broad guessing of what's actually happening inside the IT hardware. So what can be done is that actually observing the core junction temperature of the processor or motherboard temperature and also other components which data exists in the hardware hardware management, then data can be used for more precise cooling. We call this holistic cooling control, and we did experiments on this with what is the benefits we can reach by actually not only relying on rack inlet temperature sensors, but actually taking control over what's happening inside the hardware and what is actually our target processor temperature. So that's a very interesting question. Do we have a target processor temperature? If not, why not? If yes, what can be done if we have a processor target temperature? Second item is we are using grid most of the cases. So grid has an emission impact that needs to be addressed. I don't know how many of us who are listening today knows that what is the grid emission per kilowatt hour they are using, and what is compared to Indonesia, Malaysia, Europe, US, and to other countries, and what is the target of the government in the future regarding these targets. So it comes back to the Paris Climate Agreement, of course, but it is actually impacting our life on a daily basis. So now we are facing a kind of lifting new data centers. So you cannot build new data centers in Singapore. New data centers in Amsterdam and major cities was blocked because of this reason. So it is having an impact directly into our everyday operation. So that's why we need to address the data centers, the next, let's say, disruptive or next generation data centers, to make them ready to go less emission or emission free if possible. Thank you.
Okay, thank you for that very comprehensive answer, Tamas. That's very interesting indeed. So if we can move on to our next slide, please. So in your experience, perhaps start with Joshua, what is the cost of an inefficient data center, and what impact does that have on businesses and customers?
All right. I think this carries on from what we shared earlier. Our priority is always with reliability, is always with availability. But having said so, I think increasingly customers and stakeholders, they are aware of their corporate social responsibility. And of course, efficiency leads to cost savings. So even if you're a selfish fella, you want to be efficient, if only because it benefits you, and ultimately it benefits the planet, it benefits everybody else. Now, what are the trade-offs here? Unfortunately, because when things are inefficient, it could mean that things are poorly designed. Poorly designed systems are bound to lead to other residual problems. So there are always going to be issues with reliability. There might be issues moving forward with regulations as well. We have seen some of the regulations hit, I think, operators. Sooner or later, it may hit stakeholders, it may hit enterprise data centers as well. So there is a cost. It's hard to quantify, but it is there. And if there are cost savings, these are cost savings that could be passed over to our end users as well. So I think that's some of the trade-offs.
Okay, thank you. Tamas, do you have a thought on that at all?
Yes, I think we are coming back to the same topic, is that who is responsible for sustainability and efficiency in data center, and is anybody in charge of that in an organization? What kind of power they have to reach higher efficiency? So I'm not naive, so I know that sustainability compared to, or efficiency compared to reliability and safety is very behind on the list. So let me address from a different point. So we have two general ways of inefficiency in a data center. Inefficiency in capacity utilization, so which is a very common in most of the data centers you are using. There are more possible capacities which you are not actually using. The second is that inefficiency is using your resources and your energy consumption at the end, which is the classic field of energy consultancy. You can show my slide. I'm very proud to see closely the testing of a new Singapore startup by Coolest DC, which is a hybrid cooling technology. So if you compare this technology, which is anything pretty common now in the data centers, the inefficiency gap between the actual cost gap between the two is huge. So adopting this is a liquid cooling solution. This liquid cooling solution actually costs the same as the air-cooled solution. The required footprint is 1/5 of the same computing capacity compared to air cooling solutions. And if we see that the PUE you can reach with this, only focusing on the cooling is also significantly less, that's quite obvious. But also, going back to my previous answer, you can actually control the processor junction temperature with this cooling more precisely, which will enable you to do more computing from the same hardware or reduce your hardware energy, processor energy consumption by maintaining lower temperatures at the junction. You cannot do that with traditional cooling, so you are forced to rely on data only. So in this case, what I can say is that the gap, the dollars actually you are using by not using such technologies, by relying with traditional technologies, are huge and can reach a significant amount per month on capex and opex basis also.
Great, thank you very much. So can we move to our next slide, please? So we talked a lot there about, you know, various technologies and what we can do, but what is the best strategy to prioritize? Do we prioritize cooling, power, the dreaded PUE, performance, or should we look at them all as a holistic package? Joshua, what do you think?
All right. I have very mixed views about PUE. On one hand, I'm
Don't
a big
we all?
fan. Oh dear. I hope I'm not going to upset a lot of our mutual friends. Now, PUE was a great idea when it was introduced quite some years back. Since then, PUE has mobilized, I think, sentiments for enterprises. It has helped us to shape the narrative. Now, having said so, if we refer to the first white paper that was published by the Green Grid, all the way up to, I think, the latest white paper published by the Green Grid, but authored by Future Facilities, I think it was likely written by Mark Seymour himself, where they highlight that PUE could be done so as a trade-off, and it must be seen holistically with other factors as well. That's why if you refer to the white paper, they talk about the performance indicator. I don't want to go down to the academics of it. I think if the audience is interested, they can Google for this. They can read up about what the Green Grid has said about the performance indicator, how PUE should be read together with other two factors. Now, I think it must be holistic, only because enterprises and even operators is about business. But sustainability is also part of good business, and increasingly sustainability will become a bigger priority. So we should prepare ourselves for that. We should strive to be more sustainable. We should strive to be more efficient. But at the same time, I think we need to be very shrewd about what is marketing and what leads to good engineering practices. Now, there's going to be a lot of overlap there. So the devil's in the details. But suffice to say that we need consultants, we need builders, we need the facilities, and I think we need the stakeholders to all speak the same language, understand some of the fundamentals, so that we can have dialogue. Because if we don't understand the fundamentals, then we are going to be in a case where the blind leads the blind. So again, the devil's in the details.
As always, and of course with PUE, it's often down to how accurate it is and where you measure it within the system. But also we need to consider other things such as WUE as well, water being a very important component, and which quite frankly at the moment is quite badly managed or measured within DCs. Thomas, if we can have the next slide, please. So H1 Systems work with a variety of solution providers for looking at efficient cooling, power innovations. What's the importance of working with other organizations for an effective efficiency strategy?
Yeah, thank you. Well, innovations are coming from many sources, and many new innovations and product developments are happening in a year also, even in a year. So our daily job is to work closely with vendors, manufacturers, academics, and other industry technologies to actually listen and learn from them. Because as an example, if we are acting as a consultant or as an auditor, this is where actually the innovation and the knowledge is coming from. So which is in our daily practice to work with with everybody what is their future product roadmap, what is their predictions of the future, and how it can be integrated into nowadays design. So if somebody starts a data center project today, it will take a couple of months to do the design and consultancy work, the procurement, and the data center will go live if they are lucky, maybe 1 year later, or even it can be 1.5 years later. In that 1.5 years, many new technologies will appear. So how you can incorporate that? So how you can make a design which is flexible to new technologies and suggestions. We had a project once where we were in a design and build contractor in that case. And after the design work, when we submitted the vendor tenders, we learned that there are new UPS technologies are coming and new rack solutions are coming. It was not compliant with the design. So we have to adjust the design to be able to be the first in the world to implement those technologies in such project. If you can show my slide, I want to highlight that this is why we decided with Fraunhofer from Germany, the 6rise from Sweden, with EcoCooling from UK and H1 Systems to build up a consortium and do a playground kind of data center, a prototype type of data center where we can test bed and we can get the data of live operation of extreme data center conditions. So this is the Boden type data center. You can Google it and find details, where we were actually able to push down the cooling PUE below 1.01, below 1% only. Of course, you can say, okay, it's in Sweden, so it's cold, it's easy. But that's not actually that easy. Even in Sweden, to reach a cooling PUE of 1%, less than 1%, is not easy to reach. So how we were able to do that is the holistic cooling I said before, and also by actually taking over the hardware fan controls and the hardware temperature controls from the IT hardware itself, so that we are able to push it to extreme limits. And we were also able to push extreme limits of the rack inlet temperatures and observe what's happening in the hardware if we are having different inlet air temperatures, and how we can extremely widen the delta T of the cold and the hot aisle, and how it is impacting the operation, the PUE. So back to Joshua mentioned that we call this total optimization process. So in case of total optimization, which is a holistic approach, WE, PUE, carbon UE, and every other UE is incorporated, even the hardware utilization, and also what amount of processing is coming out from kilowatt per kilowatt hour, which is actually what you are looking for. So that needs to result in a policy change, and that policy change, if the stakeholders adopt to this, will have different KPIs to engineers on the field to make decisions on what kind of technologies they are willing to use and what will be their operational strategies. One more sentence here, run out of time, is that I'm pretty sure that in all organizations, the SLA for a data center is unique, it's unified. Is this real? I don't think so. I'm pretty sure you have plenty of applications, and not all the applications running on their workloads, running on the same data center are equal. When I was a junior engineer, I asked this question from clients, but now I am not asking because I know the answer. So they are not differentiating between applications and workloads. That's a big mistake, and that's a big source of waste. Thank you.
That's very true. And sometimes if enterprise applications were to use the same strategies as mobility technology and use sleep states within applications, there would obviously be quite some considerable savings in utility draw. So drawing this to a close, both Joshua, Tamas, and we could also bring in Juan Carvin as well for this. In your experience, what is the typical return on investment for implementing the sustainable data center innovations? And where do you think power and cooling investments should be made in the future? Perhaps start with Joshua, please.
Sure. I think the end user space, we are beholden to the organization's priorities. I think if I were facilities, I report to senior management. Senior management's concerns is that the lights must be kept on. And because of that, that's why sometimes we tend to take on a more paranoid approach, Why do we need UPSs? Because we want to be paranoid. We want to have that comfort. We want to know that when we go back, things will continue running. Now, having said so, because senior management is now thinking more about sustainability, this is a topic that will increasingly be spoken about in the boardrooms. So I think slowly but surely, culture will change, priorities will change. In the meanwhile, I think at a working level, what we need to do is to have the right dialogues with senior management, to have the right dialogues with consultants, with our builders, with our supply chain. And I think there are certain things which to me are hygiene, common sense. And I'm sure Carvin will agree to that. But I guess the challenge would be that before all the stars are aligned, our priorities is to keep the lights on. So that's why sometimes we have to make certain painful trade-offs and decisions.
Excellent, thank you. Tamas, do you have a thought on that at all?
Yeah, can you maybe show the slide? It's a little bit provocative, but it's addressing the. So
Oh,
at
we
the
like
moment,
provocative.
yeah, it's I'm not speaking now from a consultant perspective. I'm maybe trying to approach from a policymaker perspective. So if you can show the slide, is if you are looking for a financial ROI, of any sustainable investment, it will be a hard time to justify at the moment because energy prices are still low and the carbon impact, the externalities of carbon is actually not incorporated in the tariffs. So the emission tariff is still not covering the real impact of the emissions which are made, because you have to be competitive with other countries, with other providers, and that competition is enforcing governments to delay tariff rise. But it is happening. So in the European Union, there is the new committee decided that no data centers can run after 2030 which are not running on sustainable energy. I don't know if this will happen or not, but that's an initiative already on the table, were announced by the new committee. We are facing similar issues in Singapore from a different perspective, but if we are if we are considering the externalities, then the ROI is actually very, very low. That financially, that's that's not happening. So that's a different thing. Okay, so that's it.
Okay, thank you. So we actually have a moral responsibility as well. But finally, Carvin, a word? And the usual phrase, the Q's 2020, you're on mute, sir.
Yeah. Yes, I'll try and summarize this as quickly as I can. I've been listening on the discussion and the argument. And my perspectives will be from a business perspective. Neither am I a tech consultant, nor am I so from operating a business. So to answer your question, return on investment, it's going to come from two perspectives. One is that if I have an existing data center, what should I do? Obviously, depends on where we are. So we would do little bits to fine tune it. The target, however, would be not as grandeur as you make it to be about efficiency and whatever. It's about driving more revenue. That's the fact of life. So based on that, the key area that I believe a lot of old data centers will be working on is cooling, because that's the limitation today of all existing data centers. So I believe that they'll focus on the cooling function, fix it, and increase their yield and keep the lights on, so to speak. Now, the more challenging thought about return on investment, and I will take away the word return on investment, the more challenging thought would be the next data center that we build. What should we be doing with all this technology? That is a bigger question, because it's no longer about return on investment, it's about making the right investment, right? So if you go and continue to be investing in diesel as a backup system, and then you're going to be stuck with that model for the next 10 years, because that's the depreciation. If you go forward to continue to be investing in UPSs without understanding where the technology is heading, you're going to be stuck with it. So in the next session, I hope to highlight some of these changes. But essentially, the second decision that we as business people have to make is a more tougher one, in order to understand at which stage should we start looking at deploying this new technology. One of the key agenda, however, and motivation is about renewable, is about sustainability. It has to be. And on that basis, I want to share with you that, so DC First, we've been working really hard for the last 6 to 8 months now to redesign the data center from inside out. I can review here that Tamas is one of the key consultants that's been helping me to rethink and to review how do we redesign data center from inside out. And some of this learning that we have, and I will share it in the next session. Having said that, one of the most amazing things that I find out is that you've got to throw everything out, your business plan, your model, everything, throw it out and start from the beginning. So it's about building a new spreadsheet, and you can use the standard way of looking at total cost of ownership. It's going to be completely new. You have to start with a white piece of paper and sit down and say, what are we going to do? And if you saw the model that Tamas shared with you, that was the fundamental schematic model that we came up with in understanding how to think about the challenges of constructing the next generation data center. So I'm going to end it there. Thank you very much.
Lovely, thank you very much for that. And of course, the thing is, just because that's the way we've done it before, doesn't mean it's the way we have to continue to do it moving forward. So, gentlemen, Joshua, Tamas, and Carvin, thank you for your comments. We'll hand briefly back now to Devon.
Thank you.
Thank you, Joshua and Tamas, for those fantastic insights. Many governments around the world are implementing carbon neutrality. Many, carbon neutrality regulations and green data center standards to improve efficiency and sustainability. So it really is crucial for data center operators to explore implementing sustainable power and cooling solutions. I'd like to hand it back over to James for our next panel discussion.
Okay, thank you, Devon. Looking now at power and cooling technologies for sustainable DCs, I just want to run a little factoid past people to think about. I think most people on the call have performed at least one Google search maybe today. How much energy did that take? Well, it's actually taken enough energy to light a 60-watt light bulb for 17 seconds. The average person may produce 1,500 Google searches a year. Some people, mentioning no names, Stuart Crowley, the editor, may do a lot more. But those 1,500 searches will produce enough carbon emissions to power your car 1 kilometre down the road. So just because you don't see a meter running in the corner of the screen anymore, there is a cost. So data center demands are rising across the world. And as more businesses are digitally transforming, internet penetration is increasing. This increases the need for higher power density in data centers. From what we used to have several years ago at 2 to 3 watts a rack, kilowatts a rack, we're now seeing 8 kilowatts or more. So when we look at our next slide, please. Carvin, what do you think, or what innovative and sustainable solutions are available to cool data centers?
Hi, yeah. If you talk, let's work at since your question on cooling first. The cooling part, there are, as you have seen in the earlier panel, Tamas has introduced the concept of liquid cooling. And liquid cooling is actually not really new. I mean, I go back long enough to tell you that the first IBM mainframe computer were actually liquid cooled. Now, the difference today is the extent at which we have been trying to understand how we can be more efficient at delivering that cooling system to the parts that's most important. I think what we see today in the liquid cooling system will be the way going forward. I can say that in various discussions with the hardware vendor, I'm talking about the compute hardware vendor and the chip manufacturer, we are going to see an increase in power consumption and heat generation in the future architecture of the CPU and the GPU that's coming out. So air cooling will no longer be a valid option to effectively cool those future computers. So what we will move towards is various approach of liquid cooling that's in the market today, and there are about 6 or 7 different variations, all of which are usable, but it's a matter of choice based on the criteria that you select. Okay, so that's how I see it, and therefore the cooling technology is actually moving at a very quick and rapid pace in transforming itself to be very different from the one we know, fundamentally moving away from air.
Yeah, and I think
I would like to end that.
Sorry.
I'd like to end to say that the thinking we have as a data center operator is that cooling will now become what I call an ambient feature. So I would not design high density cooling feature. Most likely, the data center provider will provide what I call an ambient capability, and then we will then have to address each individual customer demand for different type of cooling technology implemented. Thank you.
Great, thank you, Carvin. And I think it's interesting the different types of cooling technology that are around. But Clinton, just turning to yourself for a moment, and in case people are wondering, Clinton and myself are maintaining good social distance this morning. We're only 17,000 kilometers apart. And probably Clinton think that's a good thing as far as I'm concerned. But containerized and modular data centers and solutions are being adopted much more frequently, and there's a lot of talk about edge as well and a unique cooling solution for those facilities. Why do you think that is, Clinton?
Well, I think the cost is a big factor. I think to cool an entire facility with the different cooling technologies, you end up cooling a lot of blank space or areas that are not actually occupying any IT equipment. With edge data centers, micro data centers, pico data centers, there's a lot of different names for what is essentially a very small or condensed space for the IT equipment. We work with partners as well as having our own micro data center products, and the customers are adopting them because you're able to really I'm going to use the word monitor, but it's a lot easier to monitor a smaller space than it is a larger space. And with the technology of high density computing and cramming more compute power into a smaller space, you're able to achieve quite a lot with a small space. And having it over a distributed environment, the cooling aspect of it starts to become less of a not a focus, but it's less demanding for a smaller space. Therefore, you can actually adopt more alternative cooling methods for a smaller space, because there are a lot less variables to consider.
Right, thank you. So I think if we can move to our next slide, please. I think it's true to say that the industry that we're in, Carvin, loves innovation, as long as it's been around 20 years and we're not the first ones to try it. But Asia Pacific is maybe somewhat reluctant to adopt advanced cooling technologies. What are the solutions that are driving market growth at this particular time?
I think at the end of the day, it's not the drive for change will not be innovation anymore. It's a matter of capacity maxed out. So if you have, let's go back to air-cooled data center. There's a finite physical limit that an air-cooled data center can give you, and it will come to a point where if that data center cannot has a sufficient power and space to grow, but is being held back because of the cooling technology, then it's no longer innovation. It's basically a requirement for you to rethink how to release that capacity, the ability for you to earn revenue. And it will be very fundamental, driven by that fact that you will now need to relook at what you want to do. And that's on the market push side. On the market pull, you will find that as customer becomes customers who are buying computers start to understand that there are different way of cooling the system, and they will adapt to that change. So there's going to be a pull factor whereby customers are going to order pre-configured servers in a rack with a cooling system embedded. So I call it an exoskeleton cooling process, where it's highly integrated into the server rack. And it's a really important development, and I want to highlight that. And I will tell you two more things. The world is evolving in the M&E space, where we will be in the next 5 to 6 years. I will tell you that we can virtualize UPSs, much as we have virtualized the compute space and created the cloud. You will get cloudified UPSs. And behind that, with the right adaptation of technology, we are going to get into the ability to virtualize cooling so that I can direct cooling specifically to a server. And as per what is discussed at the previous panel with Tamas, in some situation, if the close coordination between the mechanical space and the compute space can be highly connected, I can even define cooling to a particular application based on the application need and how important it is. So essentially, this whole concept of virtualization, the only thing I can't virtualize, by the way, James, is going to be my physical space. So that will remain a building.
I think a lot of us need to virtualize our own physical structure following COVID-19 in close proximity to the fridge. But
yeah.
maybe we can move to our next slide before we turn this into a Weight Watchers session. Now, the global data center market is forecast to is forecast to exceed a value of $27 billion by 2024. So while the APAC market is expected to grow by 8% annually, the main drivers appear to be UPS systems, lithium-ion batteries, and intelligent PDUs. So, Clinton, why are these solutions driving the market, and what innovations are coming up to benefit customers?
Well, it's really about the data. There's the data that you can get from a intelligent or programmable or network connected rack PDU, or even a wall PDU, as well as the UPSs, whether it's virtual or physical. The fact is that these technologies are providing the users, the operators, and management, and even the in some cases governments with information based on incidents, depending on how critical they are. I know of some customers that we've got in Singapore that they're heavily controlled by government regulation or policies, and the amount of data that they need to provide based on an incident is amazing. So if I could just use one quick example of the electric car. The electric car has been here now for multiple years, and it's innovated within itself, but it never came to market with a lead acid battery. We've seen lithium be able to provide cars, drivers, operators of those vehicles a lot of detailed information, and now integrating to vehicle to grid technologies. So lithium-ion batteries and intelligent PDUs are just part of the makeup of modern data centers, and even edge or other containerized type environments as well. And all I will say is it's about the data that you can get, and just how compatible or modern it is to be able to integrate with like a platform or with an API, to be able to have that application request more cooling from the air conditioning, to have an application or a server request more power, or tell a UPS that they're detecting some inconsistencies in their operation and they need to have excess power available. I can definitely see all that stuff already conceptually happening. But the fact is that you know, the technologies in the white space, in the physical landscape, is still core to anything virtual.
Yep, I would agree with that. And the point you make about data is also quite interesting. The number of times I have seen meters within the powertrain that have not been put in correctly, that are actually proving, if you believe the meters, that the data center is actually generating electricity rather than using it. So data has to be verified and trusted, first of all, clean, to be able to make sure that it's of practical use. So Carvin, with these rise of UPSs, lithium-ion batteries, intelligent PDUs, where do you think all this money is really going to go within the power industry?
Okay, where the money is going to go is going to be a difficult one. It's going to go to their pockets and coming from us people like the data center operators that are going to buy the equipment. That's the short answer. But let me share with you two things. I think the fundamental, there are two fundamental philosophy that's driving change. I always want to kind of strip everything down to understand, you know, innovation is just a big word, but what's driving this innovation, right? Beside the fact that we need to do something. So the first thing is we've already had loads of data around the equipment, whether it's UPS, switch gears, or whatever. We never collect them, we never store them, but it's generated by this equipment every day. It took us such a long time even to understand the energy usage of our own data center. It's not until very recent that we really truly understood, for those of us who's invested in an energy management system, that we understood where those energy is going to. As you say, are we wasting it? So no, but fundamental to this is software. More and more, and I'm going to use two words, machine learning. AI is further out, and I know we're talking about it, and I've met with a company that actually processed an AI chip that I could use to look at process control and learn about my own process control of equipment. So the possibilities are here. The key now is integrating the software element or layer into the hardware that we use today. And that leads me to the major point about what's going to happen in the UPS space. This is the immediate future. And you will see in the next year and a half, the ability for data center to be able to amalgamate our UPS pool into a bare metal process, and I can then orchestrate it so I can create virtualized sets of UPS, which I can direct that virtual power UPS based on a set of criteria that I give, and I could then assign that UPS, virtual UPS, to every individual rack, which could be different. Just one, 2N, that one, 1N, N+1. But the pool of UPS, the physical pool, would be the same. It's just that I could create this virtual image and direct that power, the power flow into the rack based on my virtualized concept. So James, it is here, and it will become major product to be available in the next 2.5 years in the industry. So that's going to be the first major impact point that I'm predicting. And I said this 2.5, 3 years ago in the same live conference, WMeter conference in Kuala Lumpur. The second major innovation, or you could call it's not innovation, but is to understand, now I'm going to deal with renewable. Renewable is not about technology, it's about fuel. It is not about technology. Let me repeat again. Renewable, the challenge of renewable, fundamentally, again, if you strip it down to the basic, is about fuel. And there are three possible renewable fuels that we have in the world today that I can think of. Water, basically hydro. Second one is the natural element, but they're not very consistent. The third one that is consistent is hydrogen as a renewable fuel. And the fourth one is nuclear. Nuclear is on the table because it is renewable, technically. So if you keep to that four element, the key thing we know today is that the financial plan for the sun and the wind and everything else, and to be able to deliver sustainable energy, is more challenging. It is possible, but more challenging, and it will be expensive if you look at the holistic process. Hydrogen, on the other hand, is a natural fuel. And I believe that one of the major changes that we're going to see is that hydrogen will become an adopted fuel of the future. And if that happens, the key technology that data center will quickly have to adopt to would be a hydrogen fuel cell. So that therein lies my feeling of how the future is going to look like. And if we can bring in hydrogen fuel cell, then the entire architecture of a data center will change. In essence, the question that will be raised is, what is the purpose of a UPS if I have hydrogen fuel cell? Thanks. I'll pass it on to you now. Back to you,
Great.
James.
Yep, the man in the blue shirt. Okay, so thank you very much, Carvin. So, Clinton, do you have your crystal ball there? What do you think we can expect to see in the next 5 years?
I don't have a crystal ball. That's as direct as I can say. I really don't know. It's changed a lot in the last few years, and I think predictions from the past have not necessarily come true, or the industry has evolved. I mean, when you look at the situation we're all in now with COVID, what impact may that have in terms of, well, the loads are no longer centralized, everything's decentralized. Maybe it's going to be rethinking how look, the landscape may change even in the next 12 months. We just really don't know. So there's some crystal ballness for you.
No, that's good. Thank you, Christian. Clinton, sorry.
Plus one to that, Clinton. Plus one to that, Clinton. I completely agree with you. And we have to watch the decentralization. But it'll be interesting. But all the technology that we've been talking about also actually will facilitate the decentralization of data center even more rapidly. It doesn't mean the core is going to go away. It means that we're going to be able to distribute the load. I completely agree with your opinion, Clinton. I think that's going to be one of the most likely direction that we will be heading in the industry.
I think that's been a very interesting discussion. Lifting the lid on all of this could sometimes be like lifting the lid on Pandora's box. So many different discussions, and I think this discussion with all our panelists could go on for quite some time to come. But of course, one thing to bear in mind, is something just to leave with people. A lot of the technologies and solutions we've spoken about are often used with new data centers. The challenge is we have a lot of legacy data centers. How do we make those more efficient? How do we increase their sustainability? There are solutions that we can bolt on, but when we're looking at replacing capital equipment, they have long replacement cycles. Carvin spoke about generators, 10 years, maybe 15 years. So to change that sort of technology takes time. So we're here for the long haul, but we have to think about where is the future going. We've had our conference today on the internet. Does that mean there has been no carbon impact? Well, yes, there has. There's been some very interesting research done just recently on the carbon impact of video conferencing that we all engage in on a daily basis. So lots to think about. Thank you very much for your contributions to our conference this morning or this afternoon. I presume it is in your case, Clinton. And glad to see that you're again upside down. So Devon, we'll hand back to you.
Thank you, everyone. It's time to put your questions to our panel. So we have questions for Clinton, for Thomas, and Carvin and Joshua. So I'll start with Clinton. We have two questions for you from Prakash and Sanjaya. You have shown the way to monitor, but what is to be done to prevent failure? And what interface protocols are supported by your rack PDUs? Question.
Okay, so first one, to prevent failure, well, that would be the need to be having historical data on how a server or service has been behaving over time. So if I could use one example, if you had a server with 2 power supplies and the power supplies were running at, say, 25% of its maximum, and it's been doing that for 1.5, 2 years that it's been installed. Then for some reason, the power load starts to increase and increase. If you were able to know what that server or application was doing in the past, you would then be able to see that something is a little bit out of the ordinary. So once if you set a baseline for your server that's running the application, then you'd be able to say, well, that's the normal operating conditions. If you are monitoring that servers from a power perspective, you don't need to get right down inside the operating system and all that sort of stuff if you don't need to. Power is really key. And the example I used for a denial of service attack, you can't see it, but when your server is under attack, the CPU usage goes up, which means that the power usage goes up, which means that the fans are spinning faster, using more power. So if you're monitoring those types of activities happening within the data center, right down to an IT device level, and you're doing that now, later, you will be able to see those trends and be able to prevent a problem from happening, or at least be able to see what's not operating how it normally should be, and you'd be able to run reports to verify that. On the second question, what protocols are supported on our rack PDUs? So the platform, I'm not going to just single out the rack PDU, but the platform that runs across the KVM switches, the power distribution units, the rack access controllers, the inline meters, and the busway tap-offs. It's a system called Xeris, and Xeris is a platform that supports all of the modern protocols, including the old legacy protocols. However, I will just say that those legacy protocols like Modbus are disabled by default because they are by nature an unsecure protocol. So even though we support multiple different protocols, SNMP, Modbus, TCP, Modbus RTU in some models. These are common industry protocols used to gather information and in some cases make changes to equipment, like changing a power state. So the protocols are modern and maintained, even down to supporting IPv6, which is not a protocol. It's a whatever it is, and you've got the service layer, like SNMP version 3 and the like. So hopefully that answers your question.
Thank you so much, Clinton. Now we have a question for our first panel from Sanjay. Thomas, how might you use server board level thermal sensors to do micro-controlled cooling? And are you using micro-cooling ducts at server level, and how is it done?
Okay. So the algorithm which we used is that we get the data of the processor temperature directly from the chip, from the server internal firmware, and that data was used in the first round to check if we are supplying enough, more or less amount of air for the IT equipment which is actually needed. So we found that during in a rack row where we have many racks, the air distribution was not optimal. So that was the first adjustment we made, is to modify the ventilation of the whole rack row based on the actual requirement. The second is that, okay, the server processor temperatures were different among the IT equipments. So that was a second stage of optimization, where this has been the control of the server fan was taken over from the hardware, overwritten by an external process. So we fixed the processor temperature at different levels. So the fans were speeding up and slowing down based on our target processor temperature, which impacted, of course, the server requirement of airflow. And that was supplied by the cooling system. So that resulted the first savings of actually how much air we need to provide. Further in the road, experiments was made to, if we increase or decrease the processor temperature, how this is changes, how this is impact the server internal energy consumption, and how it is impacting the overall data center energy consumption. We have not made internal micro ducts to distribute the air based on this. I think that's not. We try to remain on a room level orientation. So just to optimize this, to doing this in a micro level, that's a different thing.
Thank you so much, Thomas. And finally, questions going out to Kevin and Joshua. Is there any legislation on how we can use heat generated in data centers to be used more efficiently?
Joshua, you want to go first or me?
Sure. Let me go first, and I think Kavi might need a little more time. I'm not aware that there is, and in my view, it's a challenge because if you're not creating adequate heat, how do you effectively make use of it? There is heat generated. I don't dispute that, but is it worth the effort to do so? And what is the capital setup for that? Now, legislation-wise, I guess if you talk about Singapore, you're talking to the likes of BCA, IMDA, EMA. There are quite a few of them out there, and perhaps they have something in mind. I'm not aware. Probably in Indonesia, maybe Kominfo may have some thoughts on that as well. So I think let Kevin share his thoughts.
Okay, hi. Okay, there are two answers to the question. First of all, there is no legislation. Most of it is the data center deciding what to do. Actually, there's an interesting experiment we tried. There is a source of heat that's generated that is useful, actually, especially if you're running a big data center. And that is actually at the cooling tower. The cooling tower is ejecting heat that is being collected, and that heat is being ejected straight into the air. And what happened is that there's a stream of very hot air that then gets ejected from your cooling tower. There's an Australian company that builds a very light fan and it's connected to an alternator. And you can attach this fan on your cooling tower exhaust and it will generate energy. So an experiment that we've done showed that is a very more efficient way of creating usable energy than solar panel. If I was a data center, it wasn't doing a lot, but whatever it creates, there's a difference between creating energy at what price and using it. So solar, you can create energy, but the price is high. This little fan on top of my chiller tower actually was creating energy at a very low cost for me, basically recapturing the heat. So that's one simple thing that you can look at that actually works. The other thing is that Joshua is right. Based on today's technology that we have, the amount of heat that we can generate actually it has very little use for us. Okay, we can't use it to do much because it's not high enough. But if you change your electrical technology, and we've been doing this, we've been analyzing this for our new next generation data center, and if we look at introducing hydrogen fuel cell, the hydrogen fuel cell itself generates sufficient heat, and that heat is actually become very usable. And in our model, what we do is we rechannel that heat to deal with one of the biggest cooling dysfunction that has been bothering us, that keep us being inefficient with some of the even basic cooling capability, especially in the tropic, and that's humidity. And what we are looking at is to incorporate what I call, because if you use humidifier, then you do suck up electricity. So we're looking at what we call passive humidifier. These are materials that you use, much like what you do in your storeroom, but it is going to be a lot more efficient, and we will replace them with this passive material. But this material has to be regenerated each time, and the heat that we can recover from something like a fuel cell, a hydrogen fuel cell, will now be reused in order to help with the humidifying process, and therefore at zero-sum additional energy and cost to us. So that's another effective way of using of heat that's generated. But this heat can only be produced by a hydrogen fuel cell, not the normal heat that we see in today's data center. I hope that answers the question.
Thank you, Kevin. Thank you so much. That's all for our panel sessions today. The data center power and cooling markets certainly have an interesting future ahead, as innovative, sustainable techniques to power and chill a variety of data centers is becoming more and more crucial in data-intensive and climate change-aware world. I'd like to say a big thank you to all our panelists for joining us. I also like to send a big thank you to our platinum sponsor, Legrand Data Center, silver sponsor, H1 System, bronze sponsor, Onion Technology, for helping to bring this show to you. Now it's time to reveal the winner of the Amazon gift card giveaway sponsored by Legrand Data Center. Congratulations to Sanjaya from Vidyan Labs. We'll be in touch with you very soon. I'd like to thank you for joining us today. We have over 200 online attendees with us today. We will email you the recorded version of this event to share with your friends and colleagues. You can also watch this event or any of our past events on demand at w.media/on-demand. We hope you can join us again for our next digital event on September 17th. We will explore the best cloud hosting solutions for your business. And on 24th September, we will take a look at the weakest links in your cybersecurity chain with some fantastic expert speakers. If you are looking to connect with our vast network, we can help build your presence with digital marketing and event sponsorship opportunities and collaborative partnerships. So do get in touch with w.media team for more information. So all that left to say is thank you to everyone for joining us, and I look forward to hearing how you will get involved innovating future sustainable power and cooling solutions. Take care, be safe, and stay energized. So long, everyone. Thank you.
Thanks, guys.
Thank you.
Thank you.